Question 17. The curve y equals to px to the 4 plus 2x has turning point at minus 1 q. Find the value of p and q. So we have this curve here. Let's find the derivative, dy dx. That's equal to 4px cubed plus 2. And at minus 1 q, because this is a turning point, so dy dx is equals to 0, equals to minus 4p plus 2 at this specific turning point. So that gives p equals to half. So that's the first answer there. And this curve goes to this point, so we can write q equals p minus 2 by substituting negative 1 and q into the equation. And because p is half, you can put p inside here. This gives q equals minus 3 over 2. And that's the answer for q. And that's question 17. Question 18. Given the integral from 3 to k of fy dy is 3 over 2, find the integral of k to 3 of 4 fy dy. And part B, find the value of k such that the integral from 3 to k of 2 minus fy dy is equals to 4. So the first part, the integral of 4 fy dy, you just have to do two things here. First, we'll take out the constant 4 out of the integral. And second thing is to reverse the limits. When you reverse limits, the integral becomes negative. So combining that, we have negative 4, integral of 3 to k of fy dy. And we know that this thing is equal to 3 over 2. So cancel 4 and 2, we have minus 6. So that's the answer for part A. For part B, given this equation, and we have to find k. So we can split this into integral into 2. So the first one is the integral of 2 dy. So that's 2 integral of 3 to k dy minus integral of 3 to k fy dy. And that's equal to 4. And this integral is just y. So that's k minus 3. So that's just 2 into k minus 3 minus, and this thing here of course is 3 over 2, which is given above. And that's equal to 4. And if we solve that carefully, you'll find that k is equal to 23 over 4. And that's the answer for part B. Question 19. Given the graph shown here, y equals gx, and the shaded region is from x equals a to x equals to b. Part A is given some information here. Find the area of the shaded region. Okay, the information given is that the differential of 2hx is gx, but the integral of hx from a to b is minus 7. And part B, this graph passes through point 319, and given that the differential of gx is 3x squared plus 2x minus 6, find gx in terms of x. Right. So let's do the first part. We are given this graph. We're supposed to find the area. And we're also given some information where gx is the differential of 2hx. So the first thing you want to do is to transform the given information by integrating this. So integrate g of x from a to b. So if differentiate, you get hx, you get gx. So if you integrate gx, you get 2hx. So the 2 can be taken out. So this is simply 2 h of x, also from a to b. But we're also given the equation that hx from a to b is minus 7. So this means that the integral of gx from a to b is 2 times of minus 7, which is minus 14. Okay, we will use this information later. Now back to the graph. The area of the shaded region, okay, so let's call that area, is given by minus integral from a to b of g of x dx. It's minus because the area is below the x-axis. And we know that the integral from a to b of g of x is minus 14. So we'll substitute the minus 14 here. And so that gives us the answer 14. So the area of shaded region is 14. Part B. Given this relationship, so the first thing you do is we integrate this. So we get gx equals to 3x squared. So that's x cubed, and that's just x squared. That's just minus 6x, and plus some constant c. And we're also given that this curve goes through the points 3, 19. So at 3, 19, we have 19, which is gx, equals to 3 cubed, which is 27, plus 3 squared, which is 9, minus 6 times 3, which is 18, plus c. And you can work that out. And c, we find that that's equal to 1. Therefore, the function gx is just x cubed plus x squared minus 6x plus 1. And that is the answer for part B.